All right, so welcome everybody. We're going to try something new going into the second quarter. I'm going to try to film a couple more things at home. This is our spare room slash office that we have behind me. And so this will help me out going forward. I'll be able to continue to do the videos and not necessarily stay at school so late, which I have been doing. And it'll help me out for the weekends as I lesson prep and stuff like that. So if you missed today's lesson, make sure on lesson 4.4, that's what we're covering on. Make sure you go to Canvas and download the lesson so that way you can follow along with the directions. First things first, we do have bell work. So if you have the bell work worksheet, please fill that out. If you don't, please make sure you pick one up at school and then redo this lesson again. But go ahead and pause the video and work on this bell work. Alright, so what I want to make sure you guys do is if you haven't finished yet, please pause the video. If you have finished, then keep going on. So I want to highlight a couple things here, parallel, perpendicular, and perpendicular for the lines. And so all you had to do is we have to create another linear equation. The only thing you really need to do is have a slope and a point. So the point is given to you here, and the slope is always given to you in front of this original equation. Parallel would be the same slope. Distribute the terms right here, and then here is your answer, y equals x plus 2. Perpendicular slope. Perpendicular, remember guys, is take the original slope, you would flip it. In this case it's a 1, so you still flip the 1, but you multiply it by a negative as well. So negative 1 and negative and negative is positive, so my slope is going to be positive 1. Do the distribution, you'd get y equals x plus 5. The last one here, perpendicular as well. This case, the slope is 3. Flip it. 3 would be, its members 3 over 1, so it would be 1/3. Multiply a negative into it. You can kind of see the rest of it there. Pretty simple stuff. So today we're going to be talking about scatter plots and lines of fit. I want you guys to please make sure your books are open at 247. I have my book on a little stand over here. And then when you get to 247, follow along to see if you guys have any questions. We're going to be doing a lot of modeling, and we're going to actually be drawing and creating linear functions and linear equations using just scatter plots. Scatter plots are used in marketing a lot, especially with cost analysis. If anybody ever goes into the drug testing world in medical fields, you'll be doing a lot of point analysis, and then you'll have to see if there's a correlation between what you give a patient versus what you're expecting. You want to have some type of correlation dealing with that, dealing with weight loss, dealing with a whole bunch of different items. It's very statistics driven, and a lot of you guys will want to use that maybe later on down the road. We're going to create our own equations as well today using everything we've learned. So here's the vocabulary words. Bivariant data, scatter plot, correlation, association. That should be on your notes. Please annotate by circling the vocabulary word and underlining the very important processes. Alright, next here is our correlations. So positive correlation basically is dots filled in that will create a positive slope. If I were to draw a line in between them, negative correlation is kind of a whole bunch of points going kind of in a negative slope. Nor correlation is just random dots all over the place. So let's begin. So on this correlation, this graph shows the average number of students per computer at Maria's school. And what you guys have to determine whether this is negative, positive, or no correlation at all. Well, by looking at this, I could technically draw a line somewhere like that, which would show what kind of correlation? Negative. Okay, so this is a negative correlation, but then what does it mean? It means that there are less students per computer every year. So I'll pause it if I'm moving too fast. Make sure you guys get the annotation, but I want to make sure I move through this lesson relatively quickly. All right, your turn now. Look at this graph, write down if it's positive, negative, or no correlation, and then what does it actually mean? All right, on this one, guys, pretty simple setup. Positive correlation. And then what does this actually mean? That means this graph technically starts at 1980. And every year since 1980, so for example, in 2005. Okay, in 2005, the attendance was right about there at 1,750,000. Since this attendance is in thousands, I'm assuming that's 1,750,000. So, but what does it mean? It means that attendance in, attendance. Did I spell that right? Nope, I didn't. Attendance increases every year. Simple. That's all it means. It's a correlation that you guys need to make sure you understand the concepts too. Next one. So what you guys are actually going to create, though, is a linear function or a linear equation. The y equals mx plus b equations. And how you do that is first you got to make a scatter plot and determine whether there is any relationship at all. Because if there is none, then you don't have to go through the process of step 2, 3, and 4. But if there is a correlation like we've seen so far, there's a negative and a positive, then you would draw a line that seems to pass close enough to most of the data points. Okay, things have been pretty simple for you guys. If you guys look at the previous one we did here, you can kind of see the line that was drawn through these points, kind of to see how attendance at the beginning was pretty well stabilized, and then it kind of became erratic. Something weird happened, and what would that year would that be? 2001. It kind of dropped off the map. Something must have happened during that time. Maybe they have it during 9/11, I would say. Maybe that happened during this attendances during that time, and people were kind of scared during that time to go out. And then the attendance went up, or it could have been the attractions were horrible. People don't like going to livestock shows anymore. It happens, but the attendance is actually increased enough where they're back on track. So that's kind of a good correlation, especially if you're like an attendance planner. And then what you do is you draw a line, then you use 2 points on the line to write an equation. If you have 2 points, what can you do? You can find the slope, right? And then you create the line writing the y equals mx plus b. So here's our first table. And it talks about scatter plots. It gives you the lines. And so what I did is I went into Desmos and I actually plotted the lines. So you can kind of see how they create a nice little line here. And is this a positive or negative correlation? Well, it's a very steep correlation, but there is a positive correlation related to it. And then what you need to do is pick 2 lines. So if I were to connect, and you want to get lines, if I were to draw a connecting line from here, the top point to the bottom point, all of my points of reference would be on the right hand side of the equation, which is what you don't want. You want it kind of in between in both. And so what I did is I picked the points that I'll show you right now. Okay, I picked the point 2004, 6400, and then I picked 1850, 1000. So if you look on this graph, 6400 and the 2004 and the 1850, 1000 point kind of is in the middle-ish at the bottom, so it'll create a nice little line. I need the slope, so use the slope formula, y2 minus y1. So go ahead and write all this stuff down. When I put it on my calculator, I get 35.06. So I left it at that. I didn't leave it as a fraction. It makes it easier for me to kind of put this in Desmos to graph it, because that's the step. Then what you guys do is which I didn't write down, would be the point slope form, right? Which is y equals m x minus x1 plus y1. Okay, so my slope is 35.06, and then I picked the point 1850 and 1000 mainly because it's easier for me to work with 1000. You do the proper distribution. Okay, solve it. So let me change this color to red. You do the distribution on it. Okay, and when you do the distribution, you get up with 35.06x. End up with this number. Add it together, and here's your beautiful equation. Okay, go ahead and write that down. And then what you do is double check your work always. And you can actually go into Desmos, and what I did is I entered the equation, and look at that, ladies and gentlemen. There's my line of fit. That looks pretty good. Okay, you see it has a dot on the left, a little outstanding, but then the other 2 dots are on the right, and so it kind of makes it so that it's a really good line of fit. All right, next, what I want you guys to do is you guys go ahead and do this. So use Desmos, plot the points out. You kind of see how I have it set up here. Okay, now I'll zoom in while you guys are working on it, but you're going to want to pause this video right now, because I got to do some maintenance and zoom in on the points, data points that I put down. All right, work on it. Pick the 2 points that you think will be familiar for you guys, and then you go from there. Find the slope and all that good stuff. All right, so hopefully you guys were able to put in all these data points. So what I did is when I put in these data points, I noticed that there's a nice little correlation of, it's a positive correlation, right? You guys can see that if I were to draw a line of fit. And I chose on this particular equation, I chose to go along the lines of the very first point, okay, which would be down here, and then the very last point, and then I put those both in. So I picked 2 points. I picked the 2004 to the 2012 because it looked like if I were to draw a line, connect these two dots, that would be the best. Now, some of you may ask me, which ones do I pick? When it comes to the standardized test, what's going to happen, guys, is that you're going to create an equation, and all of our equations will look very similar, okay? We're going to have a similar slope. We're going to have a similar or y-intercept, the b on the y equals mx plus b. We'll all have a similar one. The standardized tests aren't going to be like if I were to pick this dot here at the top and then this dot. So let me label these real quick. If I pick the 2012 dot and the 2004 dot, okay, if somebody decided to pick the 2004 and the 2011, are you going to get a different slope? Yes. Are you going to get a different y-intercept? Yes. But on the question that's going to be given to you, will there be that slight of a margin of error? No. Okay. What I mean by that is you're going to get 4 completely different answers, okay, that won't look anything alike. And what you have to do is come to the conclusion of getting it close, okay? So you may not come out to be exact, but you need to come out to close. So if you picked a different point while you were working on this, that's fine, okay? You just would get a similar answer to me, hopefully, okay? That's the goal, is to get something similar. So I picked the first point and the last point. Hopefully maybe somebody picked 2 different points when you guys are moving along. In class today, I'm going to actually show different points to kind of show, even though I get something different, it's still along the same lines, all right? So I put in the 2 points. I got a slope of 2.89. I plugged it into the y equals mx minus x1 plus y1 formula, the point slope formula, and then this is the equation I pulled out. When I graphed that one, ladies and gentlemen, let me get rid of the labels. I graph that equation and bam, there's my line of fit. Now it's pretty cool. I get 4 dots on the left, 3 dots on the right. It's pretty good. If I were to get a different type of line of fit, that's okay, but that's just mine. And does my equation look close? Yes. Now, your goal, everybody, is to get something similar to this. So on a standardized test, you might see y equals 3x minus 5600, okay, as your equation. And guess what? You'd be able to say, well, I got something close to that, so that's got to be it. And you would be correct in that assumption. So just make sure you guys understand. And an equation like this, technically there is no wrong answer. Okay, you need to get it close and then see what the standardized test is asking you for, and you'll be able to present your data. So as a teacher, it makes it hard for me to grade, but who cares? All right, next one here. So now it's a simple last 2 examples. They give you the equation. You just need to do a prediction model. So what you do is you plug in 2025 in where x is supposed to be right here, put it in a calculator, and ladies and gentlemen, you get a population of 7,207, but we know that's in millions, so that'd be like 7 billion people. All right, 2025, if that's the prediction model, then sure, that'd be the way it goes, okay? And then the next one here, your guided practice. Use the equation from line of fit from guided practice 2 to estimate the revenue in 2030. Here is the equation, and so what you would do is you would just put it into a calculator, right, of 35.06 times 2030, and then make sure if you're going to put it all in the calculator at the same time that you put brackets around it so it knows the order of operations. So it would do this multiplication first, and then it would do the subtraction, and then you should get a revenue that is in line with the table above on example 2. I hope you guys were able to follow along and enjoy this new process. If you have any complaints or issues, let me know. But in the meantime, it's been my pleasure, and you guys have a great day, night, whenever you're watching this. But be prepared to learn, and I'm so happy that you guys are in my class. Have a great day, everybody.